So today we're learning about multiplying with exponents. There is a rule that you need to know. But first, looking at perfect squares and cubes, you should be memorizing these. You probably know most of them already. Remember, when something is squared, that really means it's being multiplied out twice. So 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. And so on and so forth. You should have these memorized. Most people know them already. It just makes life a lot easier if you have them memorized. If you don't, you can always use a calculator. Looking at the cubes over here, looking at the cubes, cubes are a little bit more difficult. You have to multiply the number altogether 3 times. So 1 cubed, or 1 to the third power, is 1 times 1 times 1, which is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which is 27. 4 cubed is 4 times 4 times 4, which is 64. 5 cubed is 5 times 5 times 5, which is 125. Again, knowing those and memorizing those, it'll be less that you have to type into the calculator. It will just help you later on, all right, in the lesson when we go to solve equations and things like that. So the rule for multiplying, there are 2 different rules that we have to know, all right? We have to know the rule when the bases are the same, all right? When the bases are the same, remember the base is the big number, all right? Think back to the first lesson. If we have 5 to the third power, the 5, the big number, is the base, all right? Remember that the 3, the little number, that is the exponent. So we're talking about when the bases are the same. Notice in all of these questions that the bases are the same. We have a 2 and a 2, a 5 and a 5, a 7, 7, 7, 2/3, 2/3, 5 and 5, 3 and 3, -6 and -6. Our big numbers are the same. Well, when the big numbers are the same, we want to keep the base the same, and we want to add the exponents. We want to keep the base the same and add the exponents. Again, we're doing this when the bases are the same. When the bases are the same, you keep the base the same and you add the exponents. 2 to the third times 2 to the fourth. We're going to keep the base the same. We're going to keep that big number the same. And then all that you need to do is you need to add your exponents. 3 plus 4 is 7. We don't type this into the calculator. We need a number that's in exponential form. So we need a number that has a base and an exponent. You wouldn't figure out what 2 to the 7th power actually equals in standard form. We want to leave it in that exponential form. 5 to the 0 times 5 to the second. We're going to keep the base the same, so we're keeping that 5 the same. We're adding together our exponents. 0 plus 2. 0 plus 2 is 2. You might have 3 numbers that you're multiplying together. Keep the base the same, so keep that 7 the same. 2 plus 3 plus 4. 2 plus 3 plus 4 is 9. So we have 7 to the 9th power. If you have fractions, you're going to treat it the same exact way. We have 2/3 inside parentheses. We're going to keep that base the same, but we're going to add our exponents. 4 plus 3 is 7. 5 to the -2nd times 5 to the 5th. You might have some negative exponents. All right, we're going to follow that same rule. Keep the base the same, so keep that 5 the same. Add your exponents. -2 plus 5 is +3. 3 to the -2nd times 3 to the -1st. Keep that base the same. Keep that 3 the same. We're going to add together our exponents. -2 plus -1 is -3. And we could just leave it like that. We don't have to convert it or anything. -6 to the 7th times -6 to the 3rd. -6 is inside parentheses. That's our base. It's staying the same. Add together our exponents. 7 plus 3 gives us 10. When the bases are different, all right, now we're talking about when the bases are different. Notice that we have a 2 and a 3. We have a 2 and a 3. All right, our bases are all different. When the bases are different, you want to just type it right directly into the calculator. All right, type it right directly into the calculator, exactly how it says. So we could figure these out separately. All right, we could figure out that 2 to the 3rd is 8, and we could figure out that 3 to the 4th is 81, and then multiply 8 times 81 together. You could do it that way, but you're allowed to use a calculator for this. So you could just type this directly into the calculator exactly how it looks. So what you would type into the calculator is you would type in 2 caret button. Again, if you're using a different calculator, it might be y to the x or x to the y. 2 caret button 3 times 3 caret button 4 and hit equals. So when you do that, you get 648. We're putting these answers in standard form, just as a plain number. When the bases were the same, we have to leave it in exponential form with a number and an exponent, a base and an exponent. But when the bases are different, we have to put it in standard form just as a normal number. We might have questions like this that, again, we have different bases. We have a 2 and a 3, but you might have negative exponents. You could figure them out individually if you wanted to, but you don't need to. Just type this exactly in the calculator, exactly how it goes. 2 caret button negative 3, make sure you're using a negative button, not the minus sign, times 3 caret button negative 2. When you do that and you hit equals, you get 0.01388888888 or 8 repeating. We could put this little repeating sign above the 8 to show 888888888. 2 to the 0 times 3 to the first. Again, they have different bases. All that we're going to do is type them right directly into the calculator, and we should get an answer of 3. So you can try these 3 on your own if you want. You can pause the video right here, and I will explain them in a second. 6 squared times 8 to the 0. They have different bases, so all that you're going to do is type it right into the calculator. When you type it into the calculator, you should get an answer of 36. 5 to the first times 5 to the negative third. The 5 are the same base. So the rule is, if we're multiplying and they have the same base, we're going to keep the base the same. So we're keeping that 5 the same. And we're going to add the exponents. 1 plus negative 3 is negative 2. 4 to the third times 4 to the second. Again, they have the same base. We're going to keep that base of a 4 the same. We're going to add the exponents. 3 plus 2 gives us 5. One last question. A lot of times on the state test, they give you a sample problem and they want you to see where the error is. So this student did 5 to the third times 5 to the second, got 25 to the fifth, and then figured it out to be 9,765,625. Where did this person make a mistake? Well, where this person made the mistake is they multiplied the bases together. All right, they multiplied the bases together instead of keeping the base the same. When the bases are the same, you have to keep the base the same. So this person multiplied the 5 and 5 to give us 25. Shouldn't have done that. He should have kept the base the same, so kept that 5 the same, and just added our exponents. 3 plus 2 is 5. So you'd get 5 to the fifth power. Again, there's 2 different rules that you need to know for this section. When the bases are the same, you keep the base the same and add the exponents. When the bases are different, just type it right into the calculator.